Hey, thanks for tuning in to a FlexCNC demo. We've got a really great one set up here for you to showcase some drilling and slotting in some C-channel, and we're going to be drilling and tapping, both thread milling and tapping, in some bar stock as well. I've got Aaron here with me, our lovely machinist and programmer, and he's going to be doing most of the heavy lifting for me. I'm just here to, I guess, help him out, but I'll let him get started whenever he's ready.
Yeah, so the first thing we're going to do, I got a piece of 1 by 2 1/4 over here in the Kurt vise. We're going to just drill 5 holes on one side of the block, 5 holes on the other side. We're going to go through in rigid tap, and we're going to thread mill each group. So I'll get started here with the program, and I can talk about it as we're kind of rolling through here. This first tool I got is the 27/64 drill. We are doing a 1/2 13 thread for both the tap and the thread mill. So like I said, 27/64 drill, we're running at 2,900 RPM at 43 inches a minute. And here's the first group of 5 holes on the left. That'll be for the tap, or I'm sorry, the thread mill, and then these 5 holes will rigid tap with our 1/2 13 tap.
So guys, as we're running this, obviously these are smaller pieces of bar stock, but you can imagine a larger plate or a larger piece of bar stock as well. We're running these smaller ones just to save on material, but still give you a good look as to what the machine is capable of.
Just to give a little insight on the machine itself, this is a Cat 50 spindle with the ZF gearbox. So this tap, as you can see right now, is orientating to position to start the rigid tap cycle. There we go, and we are running at 400 RPM, so it did kick down into low gear before it started the cycle, which if you saw the kind of the slow time there, we had to change gears, and then we oriented the spindle to the correct orientation.
And this specific machine here is our G series. It's a 20 foot by 4 foot bed, but it's got the high output package on it, which includes the ZF gearbox and a Cat 50 spindle. That allows the machine to be capable of reaching upwards of 360, 370 foot-pounds of torque to allow you to do more heavy milling applications as well as some large hole making.
The thread mill that we're going to showcase here is one from Allied Machine Tools. This is their T3 style thread mill. It's got three teeth on it, and it's a left-hand cutting thread mill. And so the way that this thread mill works is it's actually going to helix down into the hole, starting from the top. And we just finished up a live stream video with Allied showcasing some of their other thread mills. So, I mean, you'll notice that this is not going to be the fastest thread mill in this mild steel. This thread mill is actually made for more harder material. So if you were to watch the live stream, which we'll get you the link to, we did showcase some other thread mills that are full fluted. You go full depth into the hole, make one pass around to put your threads on. So As far as cycle time goes, you'll see a big difference between the tap and the thread mill, but that is because we are helixing down into the hole.
Let's show the program.
So the program that you're looking at here, what's nice about the Allied thread mills is on their website they have an option to download the online version, or I'm sorry, there's a downloadable version or there's an online version, and you simply go onto the website, select the material that you're running, select the type of the tool that you're running, what kind of thread you're putting in. They give suggestions for feeds and speeds, and then once you fill out all of the information that it's asking you, it will spit out a G&M code program for you. So as you can see, I've got 5 holes, and it's very simple as far as programming goes to just take that program that Allied gives me and just copy and paste it into the program that I create. And the only thing I have to do is, once it finishes that cycle, give it a different X and Y location where my next hole is, and like I said, it's just copy and paste. Real simple for programming this style of thread mill. And that goes for the other thread mills as well, the full fluted. Once I enter in all that information, it goes down into the full depth into the hole and creates the thread. But like I said, Allied provides all of that programming for you. So if there's any question on, what's the best way to program, how do I program it, that's what Allied's there for. It's a great tool to have, and you can utilize it for any style of thread mill that you are using.
And two, as this is running, even a machine of this size, it's capable of holding very tight tolerances. In fact, we had just ran a demo where we interpolated a 3.750 inch hole, and the tolerance came out to within 5/10. So the tolerances are clearly there, often cases far tighter than you would need on a machine this size, but that just gives you the confidence to be able to run smaller, more high tolerance parts as well, with the confidence that it's going to maintain those tight tolerances. So as you can see, we have a couple other parts over here as well, ready to set up and run. We'll be doing some C-channel here in a minute. But as you can see, the machine is capable of having a variety of different fixturing all set up at once. And while it's milling, drilling, doing what it needs to do on one part of the bed, this light curtain here, you could slide this down and be loading and unloading this part here, resulting in virtually 0 spindle downtime. The T-slots run the length of the bed here. For a 6-foot machine, you'll have 8 T-slots. This one here has 6. And you'll have a good look here also at these pneumatic vices, which can be programmed to open and close with the program on the machine, eliminating a lot of unnecessary fixturing time, tightening and opening vices. And like Aaron said, this specific thread mill, it's meant for harder materials, but it does the job here, so the cycle time's a little bit longer than normal.
Grab the air hose real quick.
Sure. So Aaron's gonna blow this off, and we'll get the good look at the finished part. How's that look, Isaac? Want to make sure we get you guys a good look. And Aaron, which side is the thread milling and which side's the tapping?
So this side here was tapped holes, and this side here was the thread milling holes.
So yeah, I mean, thread milling, it's really great. There's a lot of details in the stream we actually just completed, which the link is available on that. Obviously, you know, the flex arm is capable of tapping these holes no sweat. A thread mill is a really nice option for some of the larger holes as well. And you know, you wouldn't want to tap a hole that's, you know, 2 inches in diameter. A flex arm would probably be a better bet for that, or thread mill it. Yeah, so right now, as you can see there on the machine, it is doing these, it's drilling these holes before it will actually mill out the slots as well. So Aaron's drilling out some holes to show the drilling capability, but also give the tool area to mill out those slots. So now it's going to go and change out its tool.